Hello everyone. In this video, we will learn about a technique called a trigonometric substitution, which is going to be very useful when we are dealing with integrals whose integrand has square root of a quadratic function. Let me start with a simple function integral that we had. So remember when we were introducing the integrals, when we started the definite integral, the integral like this was one of the things that we could evaluate. And the reason was that this is going to be area under the graph of this function, which is semicircle of radius a. So then, well, we have a formula for area of circle. So half of that would give us what we are looking for. But then you may wonder, how about my integral? Let us put a equal to 1 at this point, would cover the essence of what we are looking for. How about integral, the indefinite integral of root 1 minus x squared without any limits? Because that specific limits would help us to find the translated in terms of the area of semicircle and so on. But what if I don't have any limits, and what is the antiderivative of root 1 minus x squared? If you look a little bit closely, you notice that, oh, this is not an easy integral, and every single problem comes from that root. So I have to get rid of that square root. But getting rid of square root is not easy task, unless you notice something, that if my x was sine theta, then 1 minus x squared, so 1 minus x squared will be 1 minus sine squared theta, and that will be cosine squared theta. Then if everything is inside the square root, this will come out cosine theta. So I can use that trick and get rid of square root. But this, you have to note, that is a little bit different substitution. In substitution, usually u is equal to a function of x, but here x is equal to function of the second variable theta. Well, that makes actually somehow easy for us to do integration, because now we don't need to be worried about the derivative of u somewhere in the integrand. The dx itself turns into cosine theta d theta, and well, 1 minus x squared then is 1 minus sine squared theta. And then, well, let me write equality here. Then that is root of a square, and the work that we did, there are two cosine, one coming out of square root and one from here, then we have cosine squared. So this now tells us that, okay, we are dealing with something new. By that kind of substitution, which we're going to call trigonometric substitution, we turn our integral into a trig integral. Well, trig integral, we studied these trig integrals a lot, so now I can use the technique I know from there and integrate this guy. So I'm going to go a little bit fast here. And then, okay, I'm not done unless I plug in back original variable back there. So here, if our theta is in a good range, then we can say that, okay, if x is equal to sine theta, I can go ahead and say that sine inverse x is going to be equal to theta. Okay, so then apply those ones. And you can do a very simple work here, and you can get this equality that is going to be half of x root 1 minus x squared. I strongly recommend that you go and try to go from that step to that simplification yourself and try to see how does that work. Okay, so this example, as base example, opens a big area that is new and nice. Those are called trig substitution. When does it help? When is it helpful? When our integrand has terms like this, square root of a quadratic term. Then you can do some work. Well, remember completing square? If you don't remember, you have to go back and try to figure out what does that mean. Then by completing square and some small substitution, you can turn those integrals into either that or this or that. So 3 base thing. One is a constant square minus x squared. The other one is constant square plus x squared. And the other one is x squared minus a constant square. For each one of these ones, we have a good trig function that will help us to get rid of square root. For a squared minus x squared, well, we use over there x equal to sine theta. In that case, a was 1, but here you can add a there. And then you can use substitution identity 1 minus sine squared is cosine squared. If it is plus, you can use x equals to a times tan theta, and then 1 plus tan theta will come out of the square root, and then you can use this identity get rid of square root. And if it is x squared minus a squared, a times secant theta would do the job. Okay, so this video was just an overview of what is a quadratic or a trigonometric substitution. In next videos, you will see examples and how we use the trigonometric substitution to integrate functions.